Thank you for your interest in the physics degree at the University of Aberdeen. I'm Francisco Pérez Reche, the head of undergraduate teaching, and in this video I will tell you about our department and our degree. To start with, I would like to present some dates that are important in the history of the university and physics in Aberdeen. Since an ancient university, teaching in physics actually started long ago. So here is a date, for instance, in the 1503, teaching began for the MA degree, and physics was included already at this stage. Yeah. Then here is another important date, for instance, which is that the university was a pioneer in teaching through demonstrations. You might think that is a normal thing to do for physics because it's an experimental science, that teaching is done through demonstrations, but in fact this was not always like this, and at some point then someone came up with the idea that perhaps to demonstrate the principles of physics it was good to use devices, for instance, like this one, like the Copland's balancing cube that was actually invented in Aberdeen. Yeah? And this is just something that illustrates some concepts in mechanics. Then there are other dates, like for instance in the 18th century the first physics mission was employed in a British university, and this was precisely in Aberdeen. Then in 1890s the first woman graduated, and so on. There are many important dates in the history of this ancient university. Now let me highlight two very famous physicists that were in Aberdeen at this university. Perhaps the most famous one is James Clerk Maxwell, who was one of the main physicists in history at the level of Newton or Einstein. In fact, Einstein was a great admirer of Maxwell. Yeah, and because he was so important, you can see, for instance, a blue plaque for him in the city center. Yeah. Then another very important physicist in Aberdeen is George Thomson. He got the Nobel Prize, and then, of course, he deserves the blue plaque and all the kind of honors that you can imagine for a physicist. So they were both at the University of Aberdeen, but let me introduce who are the people now at the department. Yeah. So these are the people that you would meet if you come to the university. And for instance, this is the head of department, Professor Bjorn Shelter. This is me, yeah, so you haven't seen an image of me. This is me, the head of teaching. And these are a set of very engaging staff that would teach you if you would come. So just to summarize a little bit who we are, I would say that we are a research active group of interdisciplinary physicists with a strong interest in teaching. Now, just to give some ideas of what our research is about, for instance, one of the research lines is quantum gravity and sensing. So here we design experiments and also do mathematical modeling. Then some other things that you would expect a physicist to do is, for instance, to understand materials, yeah, to understand biomaterials, oxides, smart materials, like this paper clip here, which has been trained to remember that it's a paper clip actually. Okay, so in this case, you deform the clip, and then, of course, it's not a clip anymore when you deform it, but eventually, if you heat it up, it will remember that it was a clip. Yeah. And just understanding the behavior of this material is a very challenging question. This is, for instance, if you look at the material on a microscope, it will look like this. It's something that is not simple at all. And then we have developed mathematical theories to understand why it behaves like this, why it has memory, despite being just a metal. We also do characterization of solid, X-rays, and so on. Yeah, so the kind of tools that you need to characterize materials. Then the interesting thing is that we are not only doing what you would expect a physicist to be doing, which is just perhaps studying gravitation, as I showed, or studying materials, yeah, or mechanics, but we do other things. And this is because, in fact, physics has changed a great deal since times of Newton or Maxwell. Yeah. So now physics is a discipline that becomes relevant to many other disciplines. So what this means is that if you get a degree in physics, you will be able to contribute to many other disciplines. Here are some examples. Of course, the links between physics and maths are very strong historically, but nowadays we also get very strong links between physics and biology. So physicists are trying to understand biological aspects, or the skills of a physicist are required in social sciences, in security, medical sciences. So many people in the department collaborate with scientists in other disciplines. And this is just a very enriching experience for everyone. So these are more examples in which we are moving apparently a bit away from physics, but the tools that we use are exactly the same as a physicist would use to study mechanics, these kind of things. So for instance, this is communication, neuroscience, or understanding the behavior of cells, or understand the behavior of a flock of birds. Historically, physicists were able to understand gases, which are made of many particles that just scatter each other. It's a kind of a mess. Yeah. Now, physicists are trying to understand more complicated gases, like for instance, a flock of birds. Now we also do data science. So nowadays, of course, we are flooded with data, and it's very important to understand how to better use this data to make predictions, and the skills of a physicist are very important for that. And sometimes we make it into the news with things that you wouldn't expect a physicist to be doing, which is like, for instance, design strategies to target the people that should be vaccinated to prevent epidemics, or just how to make your posts go viral. Now, just moving to our degree, what are we doing here in terms of teaching? Well, we teach for many people interested in physics. For instance, of course, we teach to people trying to get a degree in physics. This is the main purpose, perhaps. But we also teach to other people from other backgrounds that have an interest in physics, from other sciences, for instance. Yes. So we have courses that are addressed to students from other degrees that might be interested in physics. Then we also teach to students that want to be teachers. Yeah. And so on. So it's not only those people that want to be a physicist that we are teaching to, but also other type of students. Now, we try to give a wide coverage of subjects within a program, and we also encourage students to be creative, to be able to solve new problems. Yeah? And at the same time, we try to teach how to apply the fundamental concept to new discoveries. And our degree is recognized with the Institute of Physics accreditation, which is a professional body for physics in the UK. We, of course, focus on the skills that a physicist should get by the end of the degree, and this is something that is controlled by the Institute of Physics accreditation. So there are minimum set of skills that someone needs to develop in order to get a degree in physics. And a typical course would have 25% of continuous assessment. These are activities that you do during the course that will give you 25% of the marks, and then normally you get a final exam for each course, but there are exceptions. So there are courses in which everything is continuously assessed. And there are some courses in which you will have the opportunity to do some group work. For instance, there are labs in which you do group work, and group work is also done in other courses. In the final year, we do the honors project. This is an opportunity for you to work with members of staff on research projects in which you will have a taste of what doing research in physics or topics related to physics. So for instance, biology linked to physics and things like that. Yeah, so interdisciplinary approaches are also possible. We develop high quality student notes The course materials are posted on the web, including recordings of lectures, and feedback on performance is given timely and in detail. Now you may be wondering, where do Aberdeen graduates go? So if you graduate, it is not too difficult to find a job, and there are many options. So these are some examples in which, for instance, some of our students went to postgraduate studies, biomedical physics, or applied physics, data science. For instance, these are typical postgraduate studies that our students might have followed. Also, some of them become teachers, or some of them move to technical jobs like health physics, meteorology, electronic companies. So just some examples. So there are many options. Now, I would say that the physics at Aberdeen is versatile and is flexible in terms of courses that you can choose from other degrees, for instance, and I will mention more in a moment about that. And we try to always keep our materials up to date. Now, if you decide to come to this university, then the course choice, when you start, is done electronically on a system that is called OneSource. So shortly before start of the term, you will need to select your courses. And it's important that you spend some time thinking about which courses you want to choose. It's not that you have complete freedom, because in fact, there are some compulsory courses, as I will describe in a moment, that will be assigned to you automatically, and you cannot change that. So these are courses that you have to do in order to become a physicist at the end. But, well, there are plenty of options as well. And in fact, you may decide to do a joint degree. For instance, physics with geology is a popular option. Physics and maths is another option, or physics with philosophy is another option. Now you may be wondering, what are the courses that I should do in the first year? So here are the courses. Well, this is part of the courses, because I'm only showing here the compulsory ones. Compulsory are the Physical Universe A, Calculus 1, Algebra, and then in the second half should be the Physical Universe B, which is a continuation of the Physical Universe A, and Calculus 2, which is a continuation of Calculus 1. Now, these are 75 credits that are compulsory. So you need to do these courses in the first year. You may be wondering, what is 1 credit? 1 credit means formally 10 hours of work for you, and this includes contact hours for self-study, also assessments, and so on. So it means that these courses that are 15 credits, you have to spend 150 hours working in each of them. These are just the formal numbers. Of course, you can spend more, and the more you spend, the better you will do. Now, these are the compulsory, but it says also that 45 credits should be from optional courses. So these are courses that I will give some examples in a moment, but that you are free to choose. So it means that you do 75 compulsory, 45 optional. So in total, in 1 year, you have to do 120 credits. Now, this is an example of a timetable for the first half of the first year. For instance, this is a math course. So this is algebra. Then you have the Physical Universe A in the first term. You have Calculus 1. And then here you have practicals for Physical Universe A, which means you go to the lab and do practicals there. Or, well, you can have lectures. This is a lecture of Physical Universe A, and this is a tutorial. So in a lecture, the lecturer will explain concepts, and in a tutorial, you will practice them. And then you have the lab practical. Here in this example, this student would have chosen to do a chemistry course. This is an option. So there are other options. So these are part of the 45 credits that you see here, the optional courses. You could take one on computing or whatever you think you are interested in. So this is why you have to think about the options. This is an example of the second half. Well, in the second half, you continue with some maths courses and some chemistry, again, for this example, but as I said, it could be type of courses. And this is, for instance, more labs, that you get in the second term. Another option here is this ST1506, which is a statistics course, or it's called Understanding Data, which is another option that this student would have taken. Now, here are some optional courses that are directly related to physics. One of them is astronomy and meteorology, which is quite popular, and you might be interested in it if you decide to come. And this is the one I was mentioning just before, ST1506, which is Understanding Data, an opportunity to learn how to deal with data, which is a very important skill nowadays in which there are so many data around. And physicists very often end up working with just data and try to derive laws or understand phenomena just looking at data. These are just some ideas of what the courses are and the structure of the first year you would get. But now there is much more than the courses that you need to do to become a physicist. Indeed, there are societies, many societies in the university, and perhaps the ones that are more relevant for physics students are, of course, the Physics and Astronomy Society, which organizes many activities, and you would get to meet other people that have similar interests. And there is also the University Math Society, which is also relevant for students in physics. And of course, if you come, you can look at other societies that you might find interesting. Now, just to remind you that if you decide to come, don't rush your course choices. Take some time to think about it and try to make your degree outcomes as flexible as you can, given the restrictions, but it's also quite flexible, everything here, so you have options to make it flexible. And a good thing to do is to try and talk to your tutor. What does it mean? Well, it means that you will be assigned a tutor when you start in Aberdeen. This is just a member of staff in the department that will be your tutor during all your years here, and this is the person that will be able to advise you on course choice. Just to finish, these are the contact details of the department, so if you have any questions, just email us and we'll try to answer as quick as possible.